Good morning, student. In the continuous series of surface chemistry, today we discuss about the further topics of surface chemistry. In previous topic, we discussed about the adsorption. So I once again recap the absorption process. The process of attracting and retaining molecules over a surface is known as adsorption. Already we discussed some examples of adsorption. Adsorption is a surface phenomenon. I explained the adsorptions of moisture by the silica gel. So in this case, silica gel is considered as adsorbent and its mass is represented by a small m, and the molecule of water which adsorb over the surface are considered as adsorbate and their amount are represented by x, and x by m is known as extent of adsorption or magnitude of adsorption. Already these things are discussed in the previous classes or previous video, and in spite of it we discuss about the type of adsorption. Adsorptions are of two types: physical adsorption, which is also known as physisorption, chemical adsorption, chemisorption, and we explain the difference between the physical and chemical adsorptions. And also in the video, in the previous lecture video, we discussed about the adsorption isobar. It is a graphical relationship between extent of adsorption or magnitude of adsorption x by m and temperature. In the physical adsorption, all of you seen the plot of the graph is decreasing or retarding, but in the case of chemisorption, it first increases, then it start to decreases. These things are discussed in the previous video. Today we start with another topic, which is adsorption isotherms. Adsorption isotherms, the graphical representation when the straight line showing variation of pressure with temperature, straight line for a given quantity of adsorption x by m, then it is said to be adsorption isotherms. That means it is a graphical relationship in which pressure and temperature is taken in a straight line with respect to the extent of adsorption or quantity of adsorption, then it is said to be adsorption isotherm. And then we are talking about the adsorption isotherm. It is a graphical relationship between extent of adsorption or magnitude of adsorption and pressure. That means x by m depends upon the pressure. This graphical relations is known as adsorption isotherm. Adsorption isotherm is a graphical relationship between extent or magnitude of adsorption, which is x by m, and pressure at a constant temperature. And this relationship was studied by a scientist named Freundlich, and he proposed Freundlich adsorption isotherm, and it is represented as follow. Freundlich adsorption isotherm, it gives the relationship between magnitude or extent of adsorption and pressure at constant temperature. And Freundlich adsorption isotherm is written in this way: x by m proportional to p to the power 1 by n, where when we replace the proportional mark we use a constant k, then x by m is equal to kp to the power 1 by n, and experimentally it is found that the value of n lies in between 0.1 to 0.5. So we can explain graphically in this form also. Suppose that we plot a graph between extent of adsorption or magnitude of adsorption and this is the extent of adsorption, and there is a pressure at a constant temperature. Then this kind of graph is formed, and this graph is categorized in three parts. In this part, x by m is proportional to p. In this part, bent part, x by m is proportional to p to the power n, and after that x by m is independent from the pressure, and this is the saturation pressure. When x by m doesn't depends upon the pressure, then it is said to be the saturation pressure. So my dear student, all of you understand what is saturation pressure? The pressure at which extent of adsorption, that means x by m is independent from the pressure at a definite or constant temperature. So this is the useful graphical expressions of the Freundlich adsorption isotherm. Freundlich adsorption isotherm. This is the important graphical expression. Now once again we explain another graph. How does temperature vary the extent of adsorption? Temperature vary extent of adsorption. X by m, there is pressure. There are the three temperature: 195 K, 244 K, 273 K. All of you seen that on increasing the temperature, the extent of adsorption is also decreases. So at 195 K, extent of adsorption is maximum. Now how would you find out the value of x and n? The value of x and n are determined by taking logarithm both sides. Now log x by m is equal to 1 by n log p, 1 by n log p plus 1 by n log p plus log k. And then we plot a graph. And then we plot a graph in this way. In y-axis we plot log x by m, log x by m. Here log p. Then an intercept graph is obtained. This is the intercept. An intercept graph, intercept value giving the value of log k. This is intercept. And this is theta. Theta giving the value of slope. Slope is equal to 1 by n. So by plotting the graph, we can find out the value of n. Slope is equal to 1 by n and intercept is equal to log k, and this is the formula by which you can find out the value of log k and n. Understand? And this is the value of a and this give the value of b. So by using this formula, you can find out the value of k and n in this way by taking logarithm both sides. So log x by m is equal to 1 by n log p plus log k, and then we plot a graph between log x by m and log p. Then an intercept graph is obtained, and this intercept giving the value of log k and slope is equal to 1 by n. Hoping that all of you understand in a very well manner. Now further, 1 by n can have any value between 0 to 1. Case 1, when 1 by n is equal to 0, then x by m is equal to k. It means that adsorption independent of pressure. When 1 by n is equal to 0, then pressure becomes 0. So in this case, x by m becomes constant. That means it is independent from pressure. So in this case, extent of adsorption or magnitude of adsorption doesn't depends upon pressure. Now in second case, when the value of 1 by n is equal to 1, then x by m is proportional to pressure. That means when pressure increases, then the value of x by m also increases. So in this case, it depends upon the pressure. So adsorption varies directly as pressure. Both the above observation has been verified by the experimental fact. So hoping that all of you understand. Now once again we discuss the last topic related with this. What are the drawbacks or limitations? Limitations of Freundlich adsorption isotherm. So limitation Freundlich adsorption isotherm, it fails at high pressure. That means saturation pressure. It fails at high pressure. So my dear student, all of you understand that in some time in examination question is asked what are the limitations of Freundlich adsorption isotherm, then you write in a single line Freundlich adsorption isotherm fails at high pressure, that is the saturation pressure. So these are the few concepts related with the Freundlich adsorption isotherm. So hoping that all of you understand in very well manner, and it is very important for all of you because it is several times asked in the board examinations. As per the CBSE guidelines, already 30% of the syllabus are detected, so it is good chance for all the students to achieve good marks. Thank you.